Guys, please confirm to me. All of you get my voice and screen. Those are attending in online. Am I audible, guys? Please confirm to me. All of you get my voice and screen. Those are attending in online. Am I audible? Please confirm to me, guys. All of you get my voice and screen. Those are attending in online. Am I audible? Please respond to me. All of you get my voice and screen. Guys, please confirm to me. All of you get my voice and screen. Those are attending in online. All right. So, good afternoon, guys. So, in the last class, just we started. Just we started like what there Java history, that part we started there, but we have not completed that in the last session. Now today we are going to complete it, then after that we are going to start another new topic. Right, sir. Now understand it. What is this Java history? If you understand it, so from this particular topic, what you are going to understand, why the Java programming language was introduced to the market from Sun Microsystems. Majorly that point I'm going to focus here. But what exactly the background story for Java programming language, if you have to this? In 1991, Sun Microsystems had a requirement to prepare a new programming language in order to prepare softwares for the electronic consumer devices like cable TV switch boxes, remote controllers, and so on. That's the actual requirement of the Sun Microsystems in 1991. For the above requirement, Sun Microsystems gathered nearly 30 engineers as a team led by James Gosling and Patrick Norton, and Sun Microsystems has started a project named Green Project. Part of the Green Project only, this programming language was provided. Sun Microsystems had a plan to include the new feature. Sun Microsystems had a plan to include the new features in the new programming language like below. Like what are the various features that we are providing there that they are want to include? Simple programming language, tight coded programming language, architectural neutral programming language. What is the meaning of the simple programming language? If you understand the simple programming language, lesser execution time. The programming language should take less execution time. It provides more performance in the end product. Next one is what there? Less memory. Less memory provides what the less cost for the end product. Less power consumption, less maintenance cost to the end product. So these are the reasons why the programming language should be what there? A simple programming language. Next one is tight coded programming language. If any programming language takes more instructions to perform a particular task, then that programming language is a loose coded programming language. If any programming language takes more instructions to perform a particular task, then that programming language is a loose coded programming language. Example for loose coded programming language is what there? C programming language. Why? Because to perform stack operations, almost all three types of operations here we are going to perform. For each and every operation on an average, we are going to take 20 lines of code. The total 60 lines of code here we are going to consume. Okay, fine. It's a loose coded programming language. Why? Because number of instructions are more. If any programming language takes less number of instructions to perform a particular task, if any programming language takes less number of instructions to perform a particular task, then that programming language is a tightly coded programming language. It's like what the tight coded programming language. Alright, sir. Example for this tight coded programming language is what the Java is the best example. Why Java is the best example? You know, if you observe the same stack operations within 4 lines of code, we are able to complete the total stack operations. In the case of C and C++, it may take nearly 60 lines of code, but in the case of Java, it may take like what there? Only 4 lines of code. So Java is the best example for what? Tight coded programming language. Next one is after that, the third feature is what there? Architectural neutral programming language. What is the meaning of this architectural neutral programming language? If you observe this, answer is very clear. If any programming language allows its applications to perform compilation on one hardware architecture and execution is on what their other hardware architecture, then that programming language is called an architectural neutral programming language. Alright, sir. If any programming language is available to the multiple hardware systems, different hardware systems, automatically that programming language will get more demand. That programming language will get what there more demand whenever it is executing its functionalities over multiple hardware systems. Because of that reason, that architectural, that means because of this reason only, Sun Microsystems wants to prepare a new programming language. It should be an architectural neutral programming language. Okay, fine. Overall, these are the features they want to include in the new programming language. Then still we are at 1991 only. Just up to now, it is a paper plan. Just it is a plan. They want to include these features on the new programming language. Then after that, what they have done there? In 1991, Sun Microsystems started to prepare a new programming language and completed it in the end at the end of 1992. Almost all they took nearly 2 years of time to complete this programming language. They prepared it. Then after that, they want to give a name to the new programming language. Different suggestions, number of suggestions are coming from different people. Where James Gosling has given a suggestion for this new programming language, that is what their Vogue. Vogue is the name. Why he has given Vogue is the name actually? He always likes to see there is a tree. He always likes to see a particular type of tree through his cabin window at Sun Microsystems in his cabin. So by having that thought, he want to give the name for our new programming language is what their Vogue. He always likes to see a name of. He always likes to see a particular type of tree through his cabin window. That is Vogue. The tree name is what their Vogue. So he's trying to give the same name to the new programming language. But Sun Microsystems has rejected that opinion. Why Sun Microsystems have rejected that opinion there? Sun Microsystems finds that Vogue is already an existed programming language name. Already there is a programming language with the name Vogue. That's why they are not interested to give the same name to the new programming language. Now they are thinking about other name. Right, sir. While preparing this new programming language, all Sun engineers are used to take a brand labeled coffee named Java at Sun Microsystems cafeteria. So by having Java thinking, by having this thinking, almost all the Sun engineers have suggested the name Java to the new programming language. When they are giving this type of suggestion to the Sun Microsystem for the new programming language, then immediately Sun Microsystems has accepted the name Java to the new programming language. Because of that reason only, we are having the name to the new programming language is what they Java. Because of this reason only, this is a symbolic representation for Java. If we take any Java article in outside, if we take any word Java, then automatically we are able to get this type of symbol. Understand? Of course, the shapes may be varied. No, final context is what the same symbol we are able to see. Right, sir. It's okay, fine. Next one is after that. After providing name to the programming language, in 1992 December, Sun Microsystems has created the very first product on the base of the Java programming language. What was the first product that Sun Microsystems has created there? It's what their Star 7. What is the Star 7 actually? It's a remote controller, but unfortunately, it was a failure product. It was a failure product. No customer is identified up to the mid of 1994 from the end of 1992. Almost all. They waited for 1.5 years of time. They waited nearly 1.5 years of time to find customer for the Java program. That means Star 7. But no customer is identified for it. All of you observe carefully. Now understand the next one here. What I'm telling there. In the mid of 1994, there is a demand for the browsers part of the internet. In 1994, there is a demand for browsers part of the internet. That means part of the internet in the sense part of the www in internet. See, you know already one point. Throughout the world, that internet era was started in 1994. Of course, previously internet was there, but nobody knows about it. But a little bit it was there. But in 1994 onwards, that internet era was started in outside. When it comes to the India, in the year 2000 and 2001 only, that internet era was started. Observe carefully. Before that, in India, almost no internet. Then before that, but in the year 2000 and 2001 onwards, that internet, that era was started here clearly. Everybody understand this point clearly. That means the demand was going on. But previously also in one or two areas it might be available, but effectively that internet era was started in what there in 2000 and 2001 year only in India. In outside of India, in 1994 itself, that internet era was started. By the time www is having very good demand. What is the www? World Wide Web. If you want to access this www, then it is mandated to use what there? Browser. Without browser, we are unable to do anything. So definitely we require what there? Browser. That's why in the mid of 1994, there is a demand for browsers. Understand my point clearly? Right. In the mid of 1994, there is a browser. There is a browser called Mosaic. The browser name is what there? Mosaic. There is a browser named was it Mosaic, which was provided by Mark Anderson, who is an undergraduate student who prepared Mosaic browser as part of his internship in Netscape Communications. Alright, understand the point here, what I'm telling there? In the mid of 1994, okay fine, of course now I want to write in a separate paragraph. In the mid of 1994, there is a browser called Mosaic, which was provided by Mark Anderson, who is an undergraduate student who prepared Mosaic browser as part of his internship in the Netscape Communications. That means simply, in a simple words, if I want to say now, he's an undergraduate student in Illinois University at Chicago. For the sake of his project work, he went to do the Netscape Communications, is a company. In that company, part of his project work, who prepared browser. The name of that browser is what there? Mosaic browser. Even I can give that information. It took $6.25 per hour to prepare Mosaic browser, to prepare the browser. Even if you want to give that information, that one also I can give there. It took nearly $6.25 per hour to prepare like what there? This Mosaic browser. Getting it? What I'm telling you. Okay, fine. Now this is the story about the browser which is available in the mid of 1994. That's very good browser. All right. Now observe carefully, understand it clearly. By understanding the demand for the browsers, Sun Microsystems wants to prepare their own browser on the base of Java. Okay, now observe carefully. Patrick Nathan and Jonathan Payne. Were taking the responsibility of creating a new browser. Anyway, in the mid of 1994, only one browser is available that is very much famous, that is Mosaic browser. By understanding the demand for browsers, Sun Microsystems wants to prepare their own browser on the base of Java. Patrick Nathan and Jonathan Payne were taking the responsibility of creating new browser. Right. Then observe carefully, in the mid of 1994, they started to prepare new browser. By the end of By the end of 1995, new browser was generated or provided on the basis of the Java. New browser was created on the basis of the Java programming language, and the name of the browser is and the name of the browser is Hard Java browser. Observe carefully. Name of the browser is what there? Hard Java browser. Listen, I'll forget my point there. By the end of 1994, new browser was provided on the basis of the Java programming language, and the name of the browser is what there? Hard Java browser. See, because of this, then when it was there at the end of the 1994, because of this hard Java browser name only, most of the people in outside, they are thinking the Java programming language was provided in 1995. No, it was not. It was not like that. 1995, just they prepared only what their hard Java browser. It's a separate browser. It's a part of the Sun Microsystems. Sun Microsystems has created new browser by the end of 1995. Understand my point here? But they have not announced Java programming language yet by the end of 1995. They have not announced Java programming language. Just on the base of the Java, a browser was provided by Sun Microsystems. Its name is what there? Hard Java browser. Got it or not? All right, sir. Now you get the point I'm telling there, where the hard Java browser is a successful product, had very good demand. Is a successful product and it has very good demand. It had very good demand. It had very good demand in outside. Understand it clearly what I'm telling there. So from this particular point onwards, everybody they are talking about it. Hard Java browser, then how it was prepared, what was the internal technology they have used to prepare this hard Java browser. Understand my point, Ken? From that particular point onwards, everybody they are talking about Java programming language by the time. Everybody they thought of it. At Sun Microsystems, there was a programming language. It is a Java programming language. That Java programming language was used to prepare this particular product. Then everybody is thinking about like what is Java programming language. Answer my point clear, As per the request, from the vendors, Sun Microsystems has decided to release Java programming language to the outside world. Sun Microsystems decided to release Java programming language to the outside world. For this, Sun Microsystems set the date. Sun Microsystems set the date like what there? January 23rd in 1996. For this, Sun Microsystems set the date like what there? January 23rd, 1996 to release Java programming language. For the Sun Microsystems set the date January 23rd, 1996 to introduce Java programming language. That's it. By the time on that particular date, January 23rd, 1996, Sun Microsystems has released the very first version of the Java. Answer my point clearly. All right, sir. Now, similarly, right, sir. Then after this, what happened there? JDK with the name JDK 1.0, the very first version of the Java was provided. Their language introduction. Answer my point clearly. There, what happened there? Language introduction. This is the major version here we can understand. Is a major step that was taken by Sun Microsystems with the name JDK 1.0 version in 1996. But in every 2 years of time or 1 year of time or 4 years of time, 5 years of time, every periodically they are introducing new versions in the case of Java. Then after this JDK 1.0, next one is what there? JDK 1.1 they have introduced. Next one is what there? JDK 1.2 they have introduced. But JDK 1.2 is a major version. JDK 1.2 is a major version. From the JDK 1.2 onwards, the terminologies are introduced like what there, J2SE, J2EE, and what next one again? No, J2ME. These terminologies were introduced along with what there, JDK 1.2 version only. Is it? All of you getting my point or not? Okay, fine. This is the point here we have to understand clearly. Okay, fine. After that, the next one is what there. JDK 1.3 is a light version. JDK 1.4 is a nominal namesake version only. Again, the next version is what there. JDK 1.5 version is a major version again. Whenever I'm saying that major versions, no, there more and more number of enhancements are provided. More changes are available. Almost all we can understand clearly. 70% of the Java was introduced in this particular 1.2 version only. The 70% of the Java at present, whatever the Java we are seeing, that overall 70% of the Java among the Java at present was introduced along with what there 1.2 version only. Everybody understand it clear? Next one is after that, after completion of this JDK 1.5 version, another thing is like what the next one is JDK 1.6 version is a namesake version, and JDK 1.7 is also a namesake version. After this, another major version is what there JDK 1.8 version. Again, there huge number of updations are available. More and more number of updations are available. JDK 1.8 version. Almost all after introduction of the JDK 1.7, they took nearly 4 to 5 years of time to introduce this 1.8 version. There in the 1.8 version, very good. Like what I'm telling there, changes are available there. Number of changes are available. What are the various changes are available there? Annotations is a topic. At present is ruling that entire Java, introduced in 1.8 version only. Get my point or not? Not only that, sorry. Annotations were introduced in what there? JDK 1.5 version actually. It is ruling in outside market. But along with the JDK 1.8 version, what topics are introduced there? Like lambda expressions and functional interfaces. That the functional programming was introduced in 1.8 version. Now it is ruling the market. Lambda expressions now. Observe carefully. Right, so then after this, after completion of this, next one is what there? JDK 1.9 is a namesake. The JDK 1.9 is also having number of updations, but they are failure products. They are failure features. They had very good features are available, but they are failure features. All right, what Sun Microsystems has done there, what Java people have done there in 1.9 version, almost all they copied the features from other programming languages and especially from Python. The features which are copied from Python, they're included inside what they're 1.9. So there no impact is available, even though the features are available inside this 1.9. Understand it clearly? Okay, fine. Then after this, next one is what there JDK 1.10 version they have introduced. Right. Observe carefully. Some changes are available here. Once again, I'm telling to you. Let me complete it. Then after that, next major version is what there JDK 1.11 version is the next major version. After this now JDK 1.12 is the namesake. The next one is what there JDK 1.13 is the namesake. Then after that JDK 1.14 is also the namesake. After this JDK 1.15 is also the namesake. Then after this JDK 1.16 is also the namesake. The next major version is what there JDK 1.17 version. Yeah, I will give why these are namesake versions there. I will give that information to you. There is a reason for it. I'll talk with you. No need to worry for it. Then after this, after completion of this, next versions are JDK 1.18 version and JDK 1.19 version. Then after that, JDK 1.20 version. These are namesake only. The recent highest version, the very good version, the stable version is what there JDK 1.17 version. Right, sir. These are the major versions and these are what their namesake versions. Some changes are available. Now I want to give the changes clearly to you. Observe carefully. JDK 1.0, JDK 1.1, JDK 1.2, up to 1.5, up to 1.6, up to this The Java was managed by what there? Sun Microsystems. Right from JDK 1.7 version onwards, Java is available with what there? Oracle Corporation. The change there, the change was happened 1.6 to 1.7. If you have to this up to 1.6 version, Java was maintained by Sun Microsystems. Right from 1.7 on version onwards up to the date, till the date, the Java was maintained by what? Oracle Corporation. Remember the change. After this, after completion of this, up to 1.7 version, we can conclude that Java is purely object-oriented programming language. But right from 1.8 version onwards, Java is having functional programming features. Functional programming features are included. Procedure orientations also be included here. Okay, then the style of Java programming was changed from 1.8 version onwards because of these lambda expressions, because of functional interfaces, because of some other features there. The style of writing Java programs is totally changed. Okay, fine. Up to the JDK 1.10 version, Java programming language was introduced, that versions are introduced yearly basis. 2 years once, 3 years once, 4 years once, like this. Oracle has introduced the Java programming language. But right from Java 11th version onwards, right from Java 11th version onwards, Oracle Corporation has provided standardization for releasing Java. What is the standardization they are following here? Every 6 months of time, they want to release a new version on this Java programming language. For every 6 months of time. On every 6 months of time, they want to release the Java programming language. The best example I'm telling to you, maybe, I don't know about these other examples here. Best example is what their iPhone, for example. If we take this iPhone vendor, every year, they want to release a new version in iPhones there. Understand it now? At present might be iPhone 15 is going on. In the next year, maybe on what month there, maybe September or maybe August, I don't know exactly. But on that particular year, they are going to introduce again another version. That is iPhone 16 version. And every year they're planning to change what their iPhone versions there now. It is a standardization. Similarly, on every 6 months of time, Oracle Corporation wants to provide a new release for Java programming language. When they have taken the 6 months of time is a duration, no, in that less number of features only they are providing. Previously they followed yearly wise, 3 years once or 4 years once or 2 years once, like this they're trying to prepare new version there. In that new version, they've included so many features. But when it comes to the 6 months, once a 6 months one approach, inside this, for every 6 months of time, 2 to 3 main features only they are trying to release. So because of that reason, right from the JDK 11 onwards, versions are introduced fastly. Versions were introduced in fast manner. Because of that reason, these many things here we are getting. This is one point. And one more point here we have to understand, right from JDK 1.11 version onwards, right from JDK 1.11 version onwards, Java was a licensed programming language. Java was what there? A licensed programming language. Java is licensed now. Even till the date I'm telling there, Java is what there? Licensed. But to whom it is a licensed one? To whom it is a licensed one? Not for normal, ordinary developers. For the corporate users, for the corporate use, they must take license. Java is a licensed one for the corporate users. Who are the corporate users now? Company's point of view. If you are working with any company, if you want to use Java in that company, you must take the license from Oracle Corporation. For the students point of view, for the teaching point of view, for the individual application development point of view, Java is still freeware. Java is not what there licensed one. Java is still what there freeware for what there for the students, for the individual application development, for all these still Java is what there freeware. But for the corporate users, Java is what there licensed one. Right from which version there now? Java 11th version onwards. Is that good or not? Okay, fine. All right, sir. Now like this here we are having the content, and in JDK 1.7 major change is available. What was that major change there? Springboard was introduced, like what the Springboard 3.x version was introduced. That is very much famous in outside. That Springboard 3.x version was totally implemented on the basis of JDK 11 on, sorry, JDK 1.17 version. But Springboard is widely used framework in outside. Because of implementing that Springboard on the basis of JDK 1.17 version, automatically that JDK 1.17 version is getting very good demand. Of course, there also be some features are available there, one or two features. No, there are also important features there clearly. So JDK 1.17 is a long-term version after the JDK 1.11. Now, so far up to JDK 1.20 version we are having there, but still we did not identify any long-term edition on the basis of the Java. That's it. Now this is a total awareness on like what that Java programming language and the Java history. Then the total background story of the Java, what we are having, how Sun Microsystem was provided, this entire how Sun Microsystems and Oracle Corporation have provided this total Java programming language. This is total story. Is it? All of you are getting clarity on this? At least from all these points, what I required. I don't require this entire content here. Just knowledge purpose when I'm giving these concepts here. Mainly what we have to focus on these concepts here. Only 3 points here we have to understand. What exactly the nature they want to see on their Java programming language. 3 natures. What are the 3 features they want to see there? Simple, tight coded, architecture neutral. That's it. That only the point here. Apart from that, no need to think even 1 minute also about this particular content. Leave this one. Anyway, this topic is completed here. Just try to understand it. The next one is like what there. Other concept is like what there. Java. That means that next topic is like what there. Differences between Java and other programming languages. Others. Differences between Java and others. Where what are the various things? No, C and C++. Mainly we are going to focus on what there. Differences between Java and others. Like what there. C and C++. Right. Observe carefully in that second topic, differences between Java and others, C and C++. The very first topic, the very first point here, what I'm trying to discuss with you, observe carefully. C and C++ are static programming languages, but Java is a dynamic programming language. C and C++ are static programming languages, but Java is a dynamic programming language. Observe carefully. I'm going to give some clarity about this static programming languages and dynamic programming languages. I'll give some points to you, but try to put more concentration here now. So before going to understand whether C, C++ and Java static or dynamic programming languages, before that, first we have to understand when a programming language is static programming language. When a programming language is dynamic programming language, first we have to understand these points now. After that, we will come back to the C, C++ are static and Java is what they're dynamic. First of all, let us understand these points clearly. Understand these points now, all of you observe carefully. Put more concentration. I'll ask some few questions to you, now try to answer for it. For example, this is the program which I have written. I want to say this is a C program. C program in the sense file name .c. If it is C program, .c is an extension. If it is C++ program, .cpp. If it is Java, .java. If it is Python, .py. Am I right or not? These are the file extensions we can identify now. Just understand it. This is what their C program. I have written the C program here. Everybody understand this clearly. How I have written this C program? By using which representation I have written the C program? I have written this C program by using C programming language only. But the C programming language syntaxes are what their high level syntaxes. So I have written this program by using what their high level representations, high level language representations. What is the meaning of this high level language? No, simple example I'm telling you. Into A is equal to 10. This is what high level representation. Developer friendly representation. Developers understandable representation. Now here what we have there int is what there integer. Okay, I can understand clearly. Developer can understand it. A is a variable, is equal to is an operator, 10 is a constant value, semicolon. This is totally what their high level representation. Okay, fine. I have written this program in high level. But understand my point here. Now, for what purpose here we provide this program actually? If I execute this program, I'm able to get some output. If I execute this program, then I'm able to get what there? Some output. For execution purpose only, for the sake of executing program purpose only, I've written this C program. Am I right or not? Then how we are going to execute this program? Now this is like what there? Execution. Who is performing that execution actually? C program would be executed by a machine that is called as what there? C engine. What is this actually? C engine. Nice. When we provide the C program to the C engine, when we execute that C program, then automatically we are able to get some outputs. Then automatically we are able to get what there? Some outputs. When we execute that program, automatically here we are able to get what there? Some outputs. Output values here we are getting. If you're getting it or not. Now come for this point here. C program is available. .c profile. That C program if we give to the C engine. Now the C engine is going to execute this program. It is going to generate what there? Some output. That is the actual concept. But observe carefully. Who is executing our C program? No, C engine. But what this C engine is able to understand, C engine is able to understand only low level language representations. Observe carefully. Low level language representations. What are these low level language representations actually? Int a is equal to 10 semicolon, the equivalent content is what there? 0s and 1. That is what there? Low level representation. But observe carefully. I have written the C program in a high level representation. If I send this high level represented code to the C engine, is it possible for C engine to execute this high level code? It is able to understand only what? Low level code. As it is requiring, as the C engine required low level language, but how it is able to execute this high level language directly? Is it possible to execute the high level language here? No, definitely no. It is not going to execute the high level language. All of you get my point or not? So where some communication gap is available or not? Some mismatch representations are available or not? Here we provided high level representation, but where C engine is required what there? Low level representation, there automatically some communication gap is coming or not? So because of that reason our program is not going to be executed here. But still I want to execute my program. So if you want to execute our program here, in this case now, what we have to do there, we need to use some converter. We have to use what there? Some translator. Either we have to say translator or we have to say what there? Converter. Both are same here. We need to use what there? Some translator or converter. Translator. Here we have to use what there? Translator. What we are going to do with this translator now? First we will provide the C program to the translator. Translator will convert the program from high level representation to low level representation. The low level representation will be provided in the form of a separate file. Low level representation will be provided in the form of like what there? A separate file. What is that low level representation here? We can understand clearly like what there? Zeros and ones only. Here the low level representations here we are getting. Understand it clearly. All right, sir. Now that low level representations are available in this way. Now these are like what? The low level representation. But this total low level representation is provided in the form of like what file there? .exe file. Everybody understand my point clearly. Now this .exe file contains what representations? No, low level representations here we are getting. Low level language. Low level language here we are getting. Observe carefully. When we provide this C program to the translator, this translator is converting the program from high level language to low level language. When we are getting this low level language code, if we give that low level language code to the C engine, automatically C engine will execute this low level code. C engine is able to provide what there? Some output. Now observe carefully. Here we are using translation mechanism or a translation process we have used to convert the program from high level representation to low level representation or not? Right, exactly. This translation process is called compilation. This translation process is called what there? Compilation. Everybody understand my point clearly? Directly I'm asking one question to you. What is the purpose of this compilation here? What's your understanding about this compilation? What's the need of this compilation? Translating program from high level language representation to what there low level language representation. Translating program from high level representation to low level representation. This is the purpose of the compilation. Is it? All of you get my point or not? What is the purpose of the compilation? Translating program from high level representation to low level representation. This is exactly the meaning of like what their compilation. Got it? What I'm telling to you. Okay, fine. Observe carefully. Next, one more point now. I have written my C program. I translating program from high level to low level. Okay. The low level code, if I give to the C engine can execute the program. It is able to provide some output. That's okay, fine. But observe carefully. I have written the C program. Human being has written the C program. When I have written C program, maybe chances are available to get n number of mistakes. N number of mistakes I may provide. But now in this overall process, we are not checking whether that program contains mistakes or not. Without checking that mistakes, we are compiling and we are executing the program. But before going to execute the program, first we have to check whether our program contains errors or not. Whether our program contains mistakes or not. That we have to check. After that only, we are going to execute the program. So to check the developer's mistakes, in our application, we have to go for again what their compilation. Compilation process will check the developer's mistakes in the program. Compilation process will check the developer's mistakes in the program. There, that another responsibility of the compilation is what their error checking. What is that another process? No, error checking. Because of these two reasons only, we have to perform what their compilation. Tell me, sir, what is the meaning of this compilation here? What exactly the meaning of compilation? Now tell me two reasons why we are performing compilation. What are the two reasons here? First one is what there translating program from high level representation to low level representation, and second one is what there error checking. Error checking. These are the two reasons why here we are performing like what there compilation. Sir, all of you get my point or not? All right, sir. That's okay, fine. Now listen carefully. One more point here I'm telling you. Observe carefully, all of you know. 1 minute. All right, sir. Now understand one more point here. For example, int a is equal to 10. C programming language only, int a is equal to 10 I have written. What will happen here? For this int a is equal to 10. For example, I have written this instruction int a is equal to 10 here. For this a variable, 2 bytes of memory will be allocated. 2 bytes of memory will be allocated where the data is what there 10. We can understand it what there 2 bytes of memory. 2 bytes of memory will be allocated. Its value is what there 10. Got it? What I'm telling you now. If the memory is allocated for the data by the compiler at the compilation time, come again. If the memory is allocated for the data by the compiler at the compilation time, is called static memory allocation. And moreover, I am telling there, the time when we perform compilation, that is called as what there compilation time, and is also be called as what there static time. The time when we perform compilation is called as what there compilation time, and is also be called as what there static time. The time when we perform execution, this is called as what there execution time, is also be called as like what there runtime, and is also be called as like what there dynamic time. Get my point or not? The time when we perform compilation, static time or compilation time. The time when we perform execution, execution time or runtime. If the memory is allocated for the data at a compilation time, then that memory allocation is called static memory allocation. All right. For example, if the memory is allocated for the data not at compilation time, at a runtime, if the memory is allocated for the data at a runtime, say for example, a is equal to 10, that memory is allocated at runtime for the data, then here 2 bytes of memory or 4 bytes of memory, whatever it may be, if the memory is allocated for the data at runtime, then that memory allocation is called as what there? Dynamic memory allocation. Come on guys, all of you understand it clearly? That memory allocation is what there? Dynamic memory allocation. Two types of memory allocations. What are the two types of memory allocations? No, static memory allocation, dynamic memory allocation. If the memory allocation is available at compilation time, that is called as what there? Static memory allocation. If the memory allocation is going on at runtime, then that memory allocation is what there? Dynamic memory allocation. Yes, sir. All of you are getting clarity or not? This point here. Now, observe carefully, all of you know. If any programming language follows static memory allocation, that is, the memory is allocated for the data at a compilation time, then that programming language is called static programming language. If any programming language follows static memory allocation, that is, the memory is allocated at compilation time, that programming language is called static memory allocation. If any programming language follows dynamic memory allocation, that is, the memory is allocated for the data at runtime, then that memory allocation is dynamic memory allocation. If any programming language is following this dynamic memory allocation, then that programming language is called as what there? Dynamic programming language. Example for static memory, static programming language is C and C++. Example for dynamic memory, dynamic programming language is what there? Java. Understand it clearly? Now here we can understand C and C++ are the examples for what there? Static programming languages. Next one is what there? Java. What next one here? Python, .NET. All these things are like what there? Dynamic programming languages. Why? Because they're following what there? Dynamic memory allocation. But C and C++ are following what memory allocation? Static memory allocation. That's why C and C++ are static programming languages, but Java is what there? A dynamic programming language. I think you understood our actual points. What is the difference here I'm trying to say now? C and C++ are what? Static programming languages. But Java is what? A dynamic programming language. What is the point here I'm telling to you? Observe carefully. If any programming language follows static memory allocation, if any programming language follows static memory allocation, then that programming language is called static programming language. Static programming language. Then the programming language is called what there? Static programming language. All right, sir. Then what is the meaning of the static memory allocation? If the memory allocation for the data is available at the compilation time, then the memory allocation is called static memory allocation. If the memory allocation for the data is available at compilation time, then the memory allocation is called as what there? Static memory allocation. Examples for the static programming languages are what there? C and C++. Next one is what? Next one here, apart from this, no, the same point here I need to provide about this dynamic memory allocation. If any programming language follows dynamic memory allocation, then that programming language is called dynamic programming language. Dynamic programming language. If the memory allocation for the data is available at a runtime of the application, not at compilation time, then that memory allocation is called as what there? Then that memory allocation is called as what there? Dynamic memory allocation. That memory allocation is what there? Dynamic memory allocation. Examples for these dynamic programming languages are like what there? Java and Python. Of course, so many programming languages are available. Nowadays, almost all 90% of the programming languages are dynamic programming languages only, where the memory allocation is going to be happen at a runtime only, not at a compilation time. Yes, sir. All of you are getting it or not? So this difference is completed here. The difference and its related diagram already we created here. Under this diagram also here I'm going to provide now. Try to understand it clearly. Right. Now I'm going to talk about technical concepts max from this point onwards. So finally, from this diagram, what information here we understood there? What is compilation? What is execution? We understood. Am I right or not? What is static memory allocation? What is dynamic memory allocation? Here we understood. Especially from this program, 2 points here we are understanding. What are the 2 points? No. What exactly the requirement of the compilation? What is the need of the compilation? Now tell me. To translate the program from high level representation to low level representation and to perform the error checking. Because of these two reasons only, we have to go for what their compilation. That fundamental points, that internal concepts here we understood clearly. Is that clear? All of you are getting clarity on this point now? Leave this one. After this, first difference here we completed. Next one is the second difference here I'm telling to you. Observe carefully. Nearly 9 number of differences we are having in between Java and other programming languages. Now we are understanding all these 9 number of differences. Right, observe carefully the first one. The second one is like what there? Preprocessor is required in a C and C++, but a preprocessor is not required in a Java. Preprocessor is required in C and C++, but a preprocessor is not required in Java. Right, sir. Now this is the point here we have to understand clearly. Preprocessor is required in C and C++, but preprocessor is not required in Java. First of all, here we have to understand what is the meaning of this preprocessor and where it is available in the programming languages and what is the location of the preprocessor. That point here we have to understand. Yes, sir. All of you ready? All of you ready for this now? Now I'm going to give that point clearly. Try to understand it first. Right, sir. I want to give a simple diagram. Try to understand this diagram. Yeah, I think all of you are having this document link, right? To open these notes and to view that notes content here. I think I already shared that link to you, right? Or else if you're not having that, at the end of the class, I will give that link to you. Try to get it. Why? Because the total Java classroom notes I'm going to provide through that link only. We can watch this total document. Not only this, we can download this. We can download this document also every day. Not required every day. When the topic is completed, when I'm going to change the new document, there we can download it. We can keep the document in our system directly. Okay, that's a downloadable resource. Right. Now come for this punch here. First of all, I want to give clarity. Where is the location of the preprocessor in programming languages? Where it is available? These points here we are going to understand. Okay, now understand it. For example, .c file here I have taken. What file here we have taken there? .c file. Whenever we have taken this .c, we need to perform compilation. When we perform this compilation, there we are able to get .exe files. When we have .exe file, there we need to perform what their execution. Now okay, what we required here, execution is required. Execution. When we complete this execution process, there we are able to get what their output. There we are able to get what their output. That's it. Observe carefully. C program, compilation, .exe file, execution, and output. This is entire story what we have given there. I want to go for this compilation. How this compilation is going to be performed. If you observe the compilation process there, in compilation overall 4 phases are available inside the compilation. 4 missions are working together to complete this compilation. What are these 4 missions? No, preprocessor, compiler, assembler, loader, link editor. These 4 missions are working together to perform the compilation. First one is what their preprocessor. Next one is what their compiler. Then after this, next one is what their assembler. After this, the next one is what their loader, link editor. Now, okay, we are getting all. Now, again here, if you observe this compiler internal structure, if you understand it, inside the compiler, of course, I don't require the remaining part of the diagram. I require this part only, but my required information I got there. But still, in the future, I may require that internal structure of the compiler also. That's why I'm going to elaborate this. Inside the compiler, overall phases are available. 6 number of phases are available. What are the 6 number of phases there? Lexical analysis phase, syntax analysis, semantic analysis, intermediate code generation, code optimization, code generation. These many phases are available. Lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generation. Like this, here we are having it. So this is the total structure of our content. Now my required point is what? What is the location of the preprocessor? This is preprocessor. This is the location of the preprocessor. Preprocessor is the first phase inside the compilation. Preprocessor is what the first phase inside the compilation. Understand it clearly. I'll give that point clearly. Preprocessor is the first phase in the compilation. Preprocessor is the first phase inside the compilation. Right. Then it's okay. Here I'm able to give this diagram clearly. But what is the job of this preprocessor? Location of the preprocessor is okay. What is the purpose of this preprocessor? What is the job of the preprocessor? Let's understand these points now. All of you observe carefully. In a C and C++ applications, the complete, not in application, then C and C++ programming languages, the complete predefined library was provided. The complete predefined library was provided in the form of header files. The complete predefined library was provided in the form of like what their header files. Everybody understand this clearly. The complete predefined library was provided in the form of header files. What are the examples for these header files? No, stdio.h, conio.h, math.h, and so on. These are the header files. Observe carefully. Predefined library is available in the form of header files, but I want to use that predefined library in my C program. So we have to include these header files into C program. To include these header files into the C program, we have to use hash include statements. What statements here we have to use there? Hash include statements. Observe carefully. The point is what? If you want to use predefined library, in the C program, we have to include header files into the C program. If you want to use the predefined library in C program, then we have to include header files into the C program. To include header files in the C program, we have to use hash include statement. We have to use what there? Hash include statement. Examples here I'm telling to you, observe carefully. Hash include yesterday.h, hash include conio.h, hash include math.h. Like this here, we are able to have what there? Hash include statements. Right. All of you understand it now. For example, I prepared a C program. A C program. Inside the C program, I have written these many hash include statements. Then I compiled my C program. When I compile the C program, preprocessor will perform some actions. What actions that preprocessor is able to perform there? First, preprocessor will take all the hash include statements. Preprocessor will take the provided header files names. Whatever the header files which are specified along with hash include statements, preprocessor will take all the header files names. Preprocessor will search for these header files in the C programming, that means C software. Preprocessor will take these header files names. Preprocessor will go inside the C software where preprocessor will search whether these header files are available or not. If these header files are not available in C software, preprocessor will raise an error. If these header files are available inside the C software, preprocessor will load all these header files contented to the memory. Preprocessor will load all these header files contented to the memory. Loading predefined library at the time of compilation is called static loading. Loading predefined library to the memory at the time of compilation is called as what there? Static loading. Memory allocation at compilation time, static memory allocation. Loading library to the memory at compilation time, static loading. Observe carefully. Preprocessor will perform static loading over the predefined libraries. Now the conclusion is what? The main purpose of the preprocessor is to recognize all the hash include statements in order to load the specified header files contented to the memory. To recognize all the hash include statements, to find the header files, to load these header files contented to the memory at the time of compilation. That's the main purpose of the preprocessor. I forget my point or not? Now let me conclude these points here. Observe carefully. If we compile a C program, then the compiler will perform, sorry, if we compile C program, then the preprocessor will perform the following actions. What are the various actions that preprocessor is able to perform there? First of all, what preprocessor will do there? Preprocessor will recognize all the hash include statements. Next one is what there? Preprocessor will preprocessor will search for the provided header files in the C software. Already C software we have installed it when we are going to write that C program. Alright, sir. Preprocessor will search for the header files in the C software. If the header files do not exist in the C software, then the preprocessor will raise an error. The preprocessor will raise an error. Alright, sir. If the provided header files exist in the C software, then the preprocessor will load all the header files content to the memory. Observe carefully. One small note here I am telling to you. What is that note here? Loading predefined library to the memory at a compilation time is called as what there? Static loading. Loading predefined library inside this what their header files. Simply speaking, loading predefined library or header files into the memory at the time of compilation is called loading predefined library into the memory at the time of compilation is called static loading. That's it. That is what their static loading. This part is completed here. Now coming to the conclusion, what is the requirement of the preprocessor in a C programming language? What is the need of this preprocessor here? If you observe this point here, answer is very clear. Preprocessor is required in a C and C++ applications in order to recognize hash include statements and in order to load the header files content to the memory. Because of this reason, we need what their preprocessor in a C and C++. Yes, sir. All of you get my point or not? Why preprocessor is required in a C and C++ just to recognize hash include statements. In order to load header files content to the memory, we require what their preprocessor. Observe carefully. This is the simple point about the preprocessor. But still my question is what? Why preprocessor is not required in Java? Why does that preprocessor is not required inside the Java? Why? What is the problem with this preprocessor? Why it is not required? Alright, I need to give some points here. Now try to understand it clearly. Now I want to prepare the same diagram with respect to the Java. If I want to prepare the same diagram with respect to the Java, what we are going to do now? This is not like what their .c. If it is Java, there I have to use what their .java file. Now here we are getting what their .exe file, but we don't require this .exe. When we compile the .java file, there we are able to get .class files. What files here we are able to get there? .class files. In C and C++, .exe. But in the case of Java, .class files. Observe carefully. Now inside the Java, what is not available? Preprocessor is not available. Compiler, assembler, loader, link editor. Only these three things are available inside the compilation. Preprocessor is not existent. This is the diagram related to what their Java. That's it. Observe carefully. All of you know what I am telling to you. Now, coming to the Java, why preprocessor is not required inside the Java? If you observe this, understand this, why it is not required here. In Java, all of you observe carefully. In Java, the complete predefined library was provided in the form of classes and interfaces in the packages. In Java, the complete predefined library was provided in the form of like what there classes and interfaces in the packages. Examples for packages are what there java.io, java.util. Next one is java.sql and so on. Number of packages are available. Library is available in the form of packages. But if you want to use that library in Java programs, there we have to import the packages. There we have to import what their packages. Observe carefully. In Java applications, if you want to use predefined library which is available in the packages, then we have to import the respective packages. We have to import the respective packages. If we want to use the predefined library which is available in the form of packages, then we have to import the respective packages. Now examples here I'm telling to you, observe carefully. Import java.io.star, import java.sql.star, import java.util.star. Here star is representing what there? All classes and interfaces from the package. Package is nothing but collection of classes and interfaces. In a single package, we are able to have what there? Number of classes and interfaces now. Star is representing what there? All classes and interfaces from the specified package. Got it or not? Okay, fine. Now observe carefully what I am telling to you after this. For example, I prepared a Java program. Inside the Java program, I have used all these import statements. And when and if I'm compiling the Java program, if I compile Java program, what compiler will do? What is the responsibility of the compiler? Compiler will recognize all import statements. Compiler will take all the provided packages names. Compiler will check whether these packages are available in the Java software or not. That's it. If these packages are not available in Java software, compiler will raise an error. If these packages are available inside the Java software, compiler will not raise any error. At the same time, compiler will not load any package content to the memory. In Java, compiler is not responsible for loading predefined library. Compiler is responsible for checking predefined library, whether they are available or not available. That's it. Not available, raise an error. If they are available, don't raise an error. That's it. So compiler is not responsible for loading predefined library in Java. Okay, if compiler is not responsible for loading predefined library in Java, but who's responsible to load that predefined library in Java? Right, in Java at runtime, JVM is responsible to load that predefined library to the memory. JVM is nothing but execution engine for Java programs. JVM is an engine, it is going to execute our Java program. In which way we have C engine. In the same way, JVM in the case of Java to execute our program. That JVM is able to load predefined library to the memory at runtime as per the requirement. So in the case of Java, loading predefined library at runtime is called as dynamic loading. The dynamic loading is followed by what there? Java programming language. Yes, sir. All of you get my point or not? Now let me conclude this point here now. I'm going to give that point here. Observe carefully. If we compile a Java program, then the compiler will perform the following actions. What actions that compiler is able to perform there? First one is compiler will recognize all the import statements. Compiler will search, compiler will search all the packages names which we provided along with the import statements inside the Java software. Next one is what there? After this, if the provided packages do not exist in the Java software, then the compiler will raise an error. If the provided packages are existed in the Java software, then what happened there? Then the compiler will not raise any error, and at the same time, and at the same time, and at the same time, the compiler will not load any predefined library to the memory. This is one point. If the packages, if the provided packages exist in the Java software, then the compiler will not raise any error, and at the same time, the compiler will not load any predefined library to the memory. Understand this point clearly? Okay, fine. Next one is what there in Java applications at runtime, JVM will load the required predefined library to the memory. This type of loading, this type of loading predefined library at runtime is called dynamic loading. This type of loading predefined library at runtime is called as what there? Dynamic loading. Observe carefully. Who is loading predefined library in Java? JVM at runtime, not at compilation time by the compiler. Understand this point clearly. In Java applications at runtime, JVM will load the required predefined library to the memory. This type of loading predefined library at runtime is called as what there? Dynamic loading. Got it or not? Now coming to the conclusion here. Why preprocessor is not required in the case of Java? If you come for this point, understand the point here. In Java, preprocessor is not required. Why? Because in Java, hash include statements, hash include statements, and header files, header files, and header files are not existed. Sir, got my point or not? In Java, preprocessor is not required. Why? Because in Java, hash include statements and header files are not existed. Alternatively, Java has packages and import statements. Alternatively, Java has packages and import statements which are recognized, which are recognized by the compiler and JVM, which are recognized by the compiler and JVM. So we are not going to have anything like what there. We are not going to have like what there preprocessor and its functionality is not required in the case of Java. Alternatively, we are having what there hashing dot state. Sorry. Alternatively, we are having what there packages and import statements which are recognized by both compiler and JVM. Preprocessor is not at all required. Then the diagram for this Java, in the case of Java, I given there clearly. So overall, this is what exactly the difference between like what there preprocessor and as well as like what there its existence in the case of C and C++. It is not available in the case of like what there Java. Is that all of you getting my point or not? Now we have one important interview question. What is that interview question here actually? What are the differences between hash include statement and import statement? What are the differences between hash include statement and import statements? These points here we have to understand that. All right, sir. Now these differences we are going to see on next class. I'll discuss about this difference in the next class here. After completion of these differences there, I will go for some other point. The next point will be very, very important. The point is like what there platform dependent programming languages and platform independent programming languages that we are going to understand now. Okay. So when we are going to have the next class there, not on tomorrow, on Monday, on day after tomorrow, I will take the next class. Understand it now. So no need to come for the class on tomorrow. Directly we can come to the class on Monday, and Monday onwards we are going to continue this content here. Okay. That's it. Thank you. That's all for today. We'll meet on Monday again. Thank you. Yeah, then link for this document is this one. Yeah, Akash, now try to take this link. Yeah, part of the course, then depending on the modules, different projects we are going to do there. Yeah, automatically it will cover like what is the total content. Yeah, okay, but not like in a separate course for real-time project. The concepts are going to be covered. Depending on the concepts, we are going to cover like what the some simple modules we are going to prepare. Okay, right. Thank you guys. Mhm. Huh? Hmm. Yeah.